The objective is to solve a nonlinear system of equations. When you start to solve a system of nonlinear equations, you have four options. You can isolate this variable, this one, or this one. I would not recommend choosing this one because you'll end up with a square root, and that will cause you immense amount of problems if you're unfamiliar with dealing with such. You could solve for this one, but when you do, the expression has to be plugged in for x squared, so you would end up squaring a binomial, an expression with two terms. You could get this one by itself. It only has a -1 in front of it. Or this one, in which you would have to divide by a -3, so that could make it a lot more fractions to deal with. Seems to me that the easiest thing to deal with here would be this. So we will start with -2x squared minus y equals a -2, and isolate this -y by moving the -2x squared to the right. Now we divide everything by -1. This expression is equal to y, and you can plug it in there in the blue circle for y in the other equation. When you do that, you come up with -x minus 3 times the quantity of -2x squared plus 2, and then set it equal to -1. Simplify -x minus 3 times that quantity, so it would be plus 6x squared minus 6 equals a -1. Remember, you must have ax squared plus bx plus c equals 0. We already have 6x squared and a minus x minus 6, but that -1 goes to the left and becomes plus 1. So now we must simplify our constants on the end. -6 plus 1 is a -5. Completing the square, quadratic formula, or factoring are your options for solving a quadratic equation. Anytime you have a value other than 1 here, it could be difficult to complete the square. Also, anytime you have a value other than 1 there, it could be difficult to factor it, though still possible. Just takes a little more time in some cases. Though the one thing you can always count on is the quadratic formula. So I'll do -1 plus or minus the square root of -1 squared minus 4 times 6 times -5. And on the bottom we will have 2 times 6. So now we have 1 plus or minus the square root of 1 plus, due to this double negative. 1 plus 5 times 6 is 30, times 4 is 120. So 1 plus 121 is going to give me, or 1 plus 120 actually, is going to give me 121. And then we can find the square root of 121 to be 11. So now we have two problems to do. 1 plus 11 over 12 and 1 minus 11 over 12. On the left-hand side, that would be 12 over 12, which is 1. Or on the right-hand side, it's -10 over 12, which simplifies to a -5 over 6. So you must take the 1 and the -5 over 6 back to the top of the problem and plug it in for x in one of those two original equations. So back here at the top, I think the easiest one to use would be this one. -x minus 3y equals -1. -x minus 3y equals -1. That comes from here, the first equation. The first value that we found was 1. So if we put in a 1 for x, we can solve it. For y, a -3y would equal -1 plus 1. That comes out to be 0. So clearly the answer is 0 for y. We plugged in a -1 and came back with 0, so that is one of your solutions. But remember, you must do this all over again for the other x value that you solved for. And remember, that was a negative 5 over 6. Before we do this next plug-in, this should be a positive 1. I've looked up here at this to see what we plugged in and forgot that it was positive 1, not a negative 1. So this is, in fact, a positive 1, 0 for the first solution. So here on the second equation, we have to plug in a negative 5/6. So negative 5/6 minus 3y equals a negative 1. That changes to positive 5/6, and then minus 3y equals negative 1. Move the 5/6 to the right and change the sign. So we'll have negative 3y equals negative 6 over 6 minus 5 over 6. And that turns out to be a negative 11 over 6, which we must divide by a negative 3. When you divide by a negative 3, it's the same as multiplying by a negative third. So you come out with a positive 11 over 18. And remember, we plugged in a negative 5/6, came back with an 11 over 18. So now you have your two solutions, which would be this and this. I am going to choose to isolate this y because it has a coefficient of positive 1. By doing that, I move the x squared to the right and change the sign. I now have y equivalent to this expression, and I can plug that expression in for y in the other equation. So 5x plus 3 times the quantity of negative x squared plus 7 should equal a negative 1. Expand with the 3. Distribute the 3 to get negative 3x squared plus 21, and then equals a negative 1. Remember, you need ax squared plus bx plus c equals 0, and we have a negative 3x squared and a plus 5x and a plus 21, but that minus 1 must go to the left and change to plus 1. Simplify your constants at the end to get a plus 22. The quadratic formula should help us out. A negative 5 plus or minus the square root of 5 squared minus 4 times negative 3 times 22. And on the bottom, 2 times negative 3. Under the square root sign, you should have 25 plus, due to this double negative, plus 4 times 3 times 22. And that comes out to be 264. If you add 25 and 264, you will get 289. And if you know your perfect squares up through 625, then you'll know that 289 is a perfect square. The square root is 17. So you're going to need to do a negative 5 plus 17 over negative 6, or a negative 5 minus 17 over negative 6. On the left-hand side, you will have a 12 over negative 6, which is a 2. On the right-hand side, it's a negative 22 over negative 6, which goes to 11 over 3.
Wouldn't that be a negative 2?
That should be a negative 2 there. I can't tell if I'm writing the negative and it's just not showing up, or if I forgot it, but either way, it should be a negative 2 in this spot. We need to take negative 2 and 11 over 3 back to the top. And we're going to plug it into one of these two equations. Let's try the second one for a change of pace. X squared plus y equals 7. So x squared plus y equals 7. And that comes from the second equation. We found a negative 2, so if we square that, the answer is not negative 4 for that part. It is simply positive 4. And y would be 7 minus 4, which is a positive 3. So we put in a negative 2 and came back with 3 on that one. we have to use that same equation again, x squared plus y equals 7. And we're going to plug in 11 over 3. So 11 over 3 squared plus y equals 7. That's 121 over 9 plus y equals 7. So we have to keep this y where it's at and the 7, but make it minus 121 over 9 on the right. A common denominator gives me 63 over 9 minus 121 over 9. So 63 minus 121 comes back to be a negative 58. And that's over 9. Change it to a mixed number. 9 will go into 58 6 times, which is 54, and you'll have 4 left over. Remember, we plugged in an 11 over 3, which is the same thing as 3 2/3. So we put in 3 2/3 and came back with a negative 6 4/9. So your two solutions are here. This one and this one. You can start by looking at this one up here. Even though this is a 4 next to the y, you can reduce that. You can reduce this entire equation. If you divide that entire equation by 2, you can come up with one that's a much more easier to operate. You would have x plus 2y equals 6. And if you solved for y in that case, you would come up with y being equal to a negative half x plus 3, which is a little bit more easier to deal with, and you don't have as much to worry about. But you have to plug this in for y in this equation. So you will have 2x squared plus 3 times a negative half x plus 3 equals 14. Simplify to get 2x squared minus 3 halves x plus 9 equals 14. So 2x squared minus 3 halves x plus 9, and then minus 14. You must move the 14 to the left, change the sign. You can simplify your constants at the end to come up with a negative 5. But you can also get rid of that fraction of 3 halves by multiplying the entire equation by 2. When you do that, you have 4x squared minus 3x minus 10. And you can easily use the quadratic formula of negative 3 plus or minus the square root of the quantity squared of negative 3 minus 4 times negative 10. All of that is over 2 times 4. So that turns out to be a positive 3 at the beginning, plus or minus the square root of 9 plus 160. And when you add 9 and 160, it comes out to be 169. 169 is a perfect square. So 3 plus or minus 13 over 8. And you have two problems to do, 3 plus 13 over 8 and 3 minus 13 over 8. On the left-hand side, it would be 16 over 8, which is 2, or on the right-hand side, a negative 10 over 8, which is a negative 5 over 4. You have to take those two numbers to the top of the problem and plug them in for x to come up with your values for y. So back up here to the top, you can use this one if you want, because remember, it's the same as the top equation. We just divided it all by 2, and it will still come out to be the same answer. So x plus 2y equals 6. X plus 2y equals 6. So put a 2 in for x and come back with 2 plus 2y equals 6. That would be 6 minus 2, which is 4. and divide both sides by 2 to get a 2. So I put in 2, I get back 2. But I still need to do x plus 2y equals 6 again. And this time plug in a negative 5 over 4. Plus 2y equals 6. So keep the 2y where it's at and the 6 and make this plus 5 over 4 on the right. You'll need a common denominator of 4, so it would be 24 over 4 plus 5 over 4. That comes out to be 29 over 4, which you would have to divide by 2. And dividing by 2 is the same as multiplying by a half. So that is 29 over 8. And now we need it as a mixed number. 8 goes into 29 3 times with 5 left over. 3 and 5/8. And remember, I put in a negative 5 over 4, which is the same as a negative 1 and 1/4. And I came back with 3 and 5/8. So your two answers can be found here and here.